Beyond the faint light of our sun, a very mysterious world is hidden. Beyond the last planet of our solar system and even farther than the mysterious world of the Oort cloud. In this infinite and mysterious dark space, there exists such a place. It is a place we have always dreamed of reaching. But perhaps reaching there is still a great challenge for human civilization. Alpha Centauri is our closest star system. A shining light that inspires hope in the night sky that maybe we are not alone in this universe. There is hope that this star system could become our new home. But what if one day Earth becomes uninhabitable? This star system seems like an impossible new home. But if we ever manage to cross that vast distance through sheer determination, what will we find there? A new world or another disappointment that will remind us how small we are before the universe. Get ready for an astonishing journey to Alpha Centauri because here we are going to unravel many mysteries of Alpha Centauri. This journey will be amazing, it will seem impossible, and it will make us face a truth about our universe and ourselves. They may be calling us, but at the same time they warn us that the path to them is surrounded by darkness. Alpha Centauri, a system of mystery. Alpha Centauri is not just a single star, but a system filled with complexities and wonders. It contains three major celestial bodies. Alpha Centauri A is a star that is very similar to our Sun, and it is officially known as Regal Centaurus. The second star of this system is Alpha Centauri B, which is also called Ptolemy, and the last one is the mysterious Alpha Centauri C, which is also known as Proxima Centauri. It is a red dwarf which orbits around these two at a distance of 0.2 light years, a lonely wandering star located at the very edge of its stellar family. Nearby there is a secret, a planet named Proxima B. It was discovered in 2016. This rocky exoplanet is very close to its star, at just 0.049 astronomical units away, yet it is still in the habitable zone of Proxima Centauri. So, could this be a second home for our human civilization? Is it possible? Or are there some conditions here that will forever keep this planet shrouded in mystery? Proxima is also our closest known exoplanet. At just 4.246 light years away, in cosmic terms, it seems really close. But being this close means a distance of 40 trillion kilometers. This distance is so vast that even light, which is the fastest thing in the universe, takes 4.3 years to cover it. For humans like us, who exist in this universe for just a few moments and are bound to our slow spaceships, this challenge becomes even greater. Reaching Proxima B is not just a journey, it's like making a bet with the impossible. So then, why do we dream of Proxima B? Maybe because it's a mystery waiting to be solved. A piece of the puzzle that fits perfectly into the grand narrative of our existence. But before we set foot on this unknown land, we have to face a harsh reality. A reality that asks us questions we might be afraid to face. The abyss between stars. Just think about it. The distance to Proxima Centauri is 266,000 times greater than the distance between Earth and the Sun. It's about 103 million times greater than the distance between the Earth and the Moon. Voyager 1, which is humanity's fastest interstellar spacecraft, would take 75,000 years to reach there. In 75,000 years, our civilization might have turned to dust, or we might have long forgotten that we ever launched probes called Voyager. The record-breaking Parker Solar Probe, which travels at a speed of 700,000 kilometers per hour, would also take 6,500 years to complete this trip. These numbers are not just intimidating. They remind us that in terms of technology, we are still at a very early stage of development. Reaching Alpha Centauri is not a simple challenge. It will be a journey that will demand breaking through and going beyond the limits of physics, engineering, and human imagination. And yet, when we gaze into this infinite universe, a strange question arises. Are we meant to cross it? Or does the universe hold some secrets that perhaps we shouldn't unlock? In 1905, Albert Einstein changed the way we understand our reality with his special theory of relativity. One of the many great mysteries of this theory was a bitter but clear truth. No object that has mass will be able to surpass the speed of light. This is not just a suggestion, it's a cosmic rule that cannot be broken, which is woven into the fabric of space-time. The faster it moves, the heavier it becomes. Then a time will come when it will need infinite energy to move even faster. Just think about it. If an astronaut reaches 99.9% of the speed of light, his 80-kilogram mass will increase to almost 2 tons. The closer you get to the cosmic speed limit, the bigger the challenge becomes to increase your speed. Crossing the speed of light is like trying to jump over a wall of infinite height. Nothing can take you to the other side. Even if we reach the speed of light, the journey to Proxima Centauri will still take about 4.3 years. But this is just a best-case scenario, a dream that seems almost impossible because of vast energy requirements and the laws of physics. Reaching such speeds is not just a technological challenge, but a battle against fundamental principles, and winning it would take more than technology alone. A glimmer of hope, time dilation. And yet, this universe is full of paradoxes. When a spaceship travels close to the speed of light, a strange phenomenon occurs: time dilation. A spacecraft traveling toward Proxima Centauri at relativistic speed experiences time passing more slowly for its crew. For an observer on the ground, this journey may seem to last for many decades or even centuries. But for the travelers inside the spacecraft, it will feel like only a few years. But time dilation is not just a subjective compression. Just think about it. For an observer on Earth, the distance to Proxima Centauri, which is 4.246 light years away, will take about 4.47 years to reach. But for the crew, due to time dilation, this journey will feel like only 1.39 years. The faster the spacecraft travels, the smaller this difference becomes. But if the spacecraft travels at 99.9% of the speed of light, then for the crew, a 1-year journey will feel like only 2 weeks. And if the speed reaches 99.9999% the speed of light, then a journey of thousands of light years will end for the crew in just a few decades, or even sooner. This phenomenon raises a profound question. Can relativistic travel open the path to interstellar exploration? Maybe. But time dilation is not a miracle. The energy required to reach such speeds is also unimaginable. And the dangers, such as collisions with high-energy particles, lethal radiation, and destructive interactions with interstellar matter, all these challenges are still very significant. At such speeds, even a thin layer of interstellar gas would turn into deadly plasma. For both the spacecraft and its crew, the empty space that once seemed calm and completely empty will become an invisible battleground, a battlefield where no spacecraft has survived so far. Time becomes an invisible battleground on the way to distant stars, but it also brings with it deep and mysterious barriers. Limitations of time dilation. As we saw earlier, to take a mass close to the speed of light would practically require infinite energy. So far, we haven't found any propulsion system that can make this possible, and even if somehow this energy problem is solved, even then, a spaceship traveling close to the speed of light would find space to be a very dangerous place. Space isn't empty, it's actually filled with unconnected wandering atoms, sometimes in complex forms like gas and dust clouds, galaxies. They accumulate in the form of stars and planets, and sometimes, as lone atoms, they wander through this infinite universe. In 1 cubic centimeter of space, between two hydrogen atoms, the probability of collision is a different matter. And during the journey of the spaceship, the certainty of an enormous flow of particles colliding with the spaceship is an entirely different matter. At low speeds, the particles are harmless, but with acceleration, they rain down like a dangerous shower. These projectiles and highly penetrating ionizing radiation can cause severe damage to the spacecraft, and the atmosphere inside the spaceship becomes extremely radioactive for the crew living inside. These are particles that travel at speeds very close to the speed of light. They acquire so much energy that they become a threat to any form of life. At such high speeds, even passing through a very thin nebular cloud can destroy the entire spaceship. Social and temporal disconnection, a lonely future. Even if we overcome all the technical challenges, there will still remain an impossible problem. Time dilation will have a devastating effect on the relationship between the spaceship and the home planet. For the crew aboard the relativistic ship, time will slow down significantly. But on Earth, the clock will keep ticking at its usual pace. The time that will feel like only 11 years for the crew, that will turn into hundreds of thousands or even tens of millions of years for the people left behind on Earth. This harsh truth presents us with an existential dilemma. Astronauts who embark on such a journey will have to leave behind their world, family, friends, and even their culture forever. And when they return, Earth will have completely changed for them, or perhaps it may not even be habitable anymore. The society they once left behind will have been lost in the sands of time. Either it will have transformed into some alien form, or it will have completely disappeared. The spaceship will no longer be a means of exploration, but will become their own small world, drifting alone through time and space. The effects of such temporal isolation can also be seen in the idea of the fictional United Federation of Planets, like in Star Trek. The cultural and technological synchronization necessary for trade and cooperation will break down. Would a commercial enterprise have this motivation? To send cargo on a journey where there would never be any connection with the sender again. Such a journey would not be a transaction, but rather cargo that has neither an owner nor a destination. According to the laws of Einsteinian relativity, any spaceship embarking on such a journey would actually become a self-sustained world. Completely cut off from its origin, drifting away from its purpose, would this sacrifice be worth it? This sad conclusion aligns well with Enrico Fermi's famous paradox. If advanced civilizations exist, then why haven't we encountered them yet? Maybe the answer isn't that they don't exist, rather it's in the cruel barriers imposed by the laws of this universe. Time dilation presents us with a harsh reality even if we manage to overcome these barriers. For the crew of a relativistic spaceship, time on their planet will continue to move at its usual pace. Generations will pass, civilizations will rise and fall by the time the crew returns. Their world will have completely changed for them, or perhaps even completely disappeared. So then, what would be the purpose of such a journey? A mission to Alpha Centauri is not just about crossing physical space. It will break those bonds of time and memories that connect us to humanity, that make us human. The Fermi paradox, a stark reminder. This conclusion leads us to a frightening and profound question, one that Enrico Fermi once asked. If advanced civilizations exist, then why haven't we encountered them yet? Perhaps the answer lies hidden within the very limitations that we ourselves face. The distances between stars are not just measurements of space, they are like the strong walls of a fortress of isolation. These are some barriers created by nature that hardly anyone would even try to break. These barriers probably confine every civilization to its own celestial backyard, where dreams of interstellar expansion burn like a dying flame and eventually fade away. Alpha Centauri, despite being close to us, remains just a dream, one that only the truly courageous dare to pursue. Is this only for those who, like the visitors, can sacrifice everything for their world? This idea highlights the non-existence of the visitors. This is a sign of the defeat of all civilizations. We are completely alone. A new hope, robotic explorers and light sails. But we know that where humans cannot succeed, maybe machines can. The future of interstellar exploration may be in the hands of robotic probes. Miniaturized marvels capable of traveling at fractions of the speed of light, concepts like von Neumann probes which can self-replicate and colonize. They could spread the essence of humanity to the stars. Or perhaps laser sails which would be driven by focused beams of light. Lightweight probes can be accelerated to up to 20% the speed of light. And with this, Alpha Centauri can be reached in just 21 years. These solutions are not part of science fiction but are actually very close to our reality. This journey still won't be easy and the obstacles are huge, but humanity has never backed down from doing the impossible. Will these machines one day send us secrets that we never even imagined? Even the smallest star that breaks apart in space has the power to turn any planet into dust because of its supernova explosion. But what would happen if the closest and largest star to Earth were to break apart? Yes, that's what we're talking about. A red supergiant star located 650 light years away from Earth. Betelgeuse surpasses the Sun in age, size, and temperature in every aspect. This star is continuously moving towards its destruction. So if this star explodes, what will happen to our Earth? So let's find out. Let's learn about Betelgeuse, one of the largest and brightest stars in our universe, which is becoming a threat to our Earth day by day. Betelgeuse is the 10th brightest star in our universe. Because it is even bigger than the Sun, it is also known as Alpha Orionis. Betelgeuse star, located on the left shoulder of the Orion constellation, is a 10 million year old star in our universe, which is almost 50 times older than the Sun. Today, Betelgeuse is one of the largest known stars in space. Its diameter is more than 700 million miles, that is, over 1.2 billion kilometers. If the Betelgeuse star were placed at the center of the solar system in place of the Sun, its outer surface would even touch the planet Jupiter. From this, you can get an idea of the enormity of the Betelgeuse star. But in recent years, scientists have found a decrease in its size. In fact, the bright light and massive size of the Betelgeuse star are changing rapidly over time. The Betelgeuse star is losing its mass and its outer layers at a very fast rate. Because of this, its brightness is continuously decreasing and it is becoming more red. Because it has been in space for so many years, the hydrogen fuel in Betelgeuse's core has now been completely exhausted. Its helium is continuously turning into carbon, and now it is in the final red giant phase of its life. That means the final time of the Betelgeuse star has arrived, and now it is drawing its last breaths. According to scientists, the Betelgeuse star has entered its pre-supernova phase. Maybe that's why Betelgeuse has been continuously giving signs of its supernova explosion for the past few years. Scientists believe that the reason behind this major change in the Betelgeuse star is its origin and its massive size. According to scientists, the Betelgeuse star was born with this massive size, and in the beginning, it used to be a blue-white O-type star. Inside it, a huge amount of hydrogen used to burn continuously. Now, from a scientific perspective, the bigger a star is, the brighter it shines and the hotter it is. But then, its hydrogen fuel also starts depleting just as quickly, and gradually that star begins to transform into a red giant form. Something similar happened with Betelgeuse as well. Due to continuously radiating its energy into space for the past million years, the hydrogen inside it has been depleted, and that's why the Betelgeuse star is now in the red giant stage. Not only that, when Betelgeuse exhausted its hydrogen and started burning helium, its envelope expanded far beyond its original size. Scientists claim that in its early days, the Betelgeuse star would have been 100 times brighter and 10 times bigger than the Sun. Compared to the Sun's surface temperature of 10,000 degrees Fahrenheit or 5,500 degrees Celsius, Betelgeuse's surface temperature would have been astonishingly high, reaching up to 89,500 degrees Fahrenheit or 50,000 degrees Celsius. But now, this star is not as hot as it used to be. Because its current temperature is only 5,800 degrees Fahrenheit or 3,300 degrees Celsius, which is much cooler compared to the Sun, but even then, its brightness is unmatched. The vastness of Betelgeuse star and its proximity to Earth make it even more special for our planet. This is the reason why today, with the help of the Hubble Space Telescope and radio telescopes, Betelgeuse star can be easily studied from Earth. If you look towards the Betelgeuse star with the help of any instrument from Earth, you will see a lumpy mass of boiling gas bubbles instead of a smooth ball of super hot plasma inside it. Those huge masses of hot material rise from the very center of Betelgeuse to its surface and then cool down and disappear back into its interior. For the past few years, because of its erratic behavior, Betelgeuse has been a topic of discussion among scientists. For centuries, astronomers have observed the regular 400-day cycle of the Betelgeuse star. In this cycle, they found that the brightness of Betelgeuse keeps decreasing and increasing continuously. Sometimes it increases up to a magnitude of 0.3, then decreases to about 0.8. But in December 2019, scientists observed that Betelgeuse was losing its brightness at a much faster rate, and suddenly it became 2.5 times dimmer than before. This change in the Betelgeuse star became known as the Great Dimming of Betelgeuse. Not only that, scientists also discovered a large amount of material being expelled from its interior, forming a dense cloud of dust around it. This made the entire Betelgeuse star disappear from our sight. However, now that cloud of dust has cleared and Betelgeuse has returned to its normal brightness. But it's also true that this star is no longer in its old form. Its 400-day brightness oscillation period has halved to 200 days, which means the pattern of its dimming is still continuing. Seeing these behaviors of Betelgeuse, it started being speculated that this star is about to end soon with a supernova explosion. In fact, when a star consumes all the helium in its core, it takes the form of a red giant. It starts burning carbon and oxygen into neon and magnesium. After that, it converts them into silicon. In the end, the core of that star gets filled with iron, after which those iron atoms combine with helium nuclei, and this combination produces a huge amount of energy. The core of that star starts absorbing that energy, and due to this change, the core of the star begins to collapse from the inside out. This event is known as a core collapse supernova. Supernova explosions are so bright that for a while, they outshine the entire galaxy. With the help of sensitive telescopes available today, astronomers can observe these supernova explosions. But for ordinary people like us, it's not possible to see these supernova explosions happening in some mysterious corner of the universe. But the supernova explosion of the Betelgeuse star will be very different. Because it is close to our Earth, its explosion will be clearly visible even during the day. The supernova explosion of the Betelgeuse star will light up our sky with its brightness for a full 2 months. During this time, there will be so much intense light on our Earth that even if the electricity of the whole city is cut off at night, there will be no sign of darkness. A similar supernova explosion was also seen in the year 1604, which is also known as the Kepler supernova, which filled the sky with light continuously for 3 weeks. Now, even though Betelgeuse star is also on its way to a supernova explosion, it will still take thousands of years for it to explode. explode. Most astronomers believe that Betelgeuse star is still in the early stages of its supernova explosion. Now it is fusing helium, which is a long process that takes millions of years, so it will still take thousands or even millions of years for the Betelgeuse star to explode. That means this amazing sight is still thousands of years away from our eyes. However, it's still a bit difficult to look into the core of the Betelgeuse star and see what the state of helium fusion is there. And Betelgeuse is present in the Orion constellation. It is believed that compared to our process, this explosion is increasing rapidly. And no one knows when this explosion will happen. Scientists believe that Vaikma could have been seen 100 years ago from today, but it has lost almost 60% of its material, and because of that, it can now only be seen in infrared. That's why many astronomers still consider Betelgeuse star's red giant form to be in its early stage. There were many speculations about Betelgeuse that this massive star could soon end in a supernova explosion. Recently, a decrease in its brightness was also observed, and we kept waiting, but nothing happened with this star as we had expected. This star has remained a mystery, but the recent discovery about its brightness, actually, it's about Betelgeuse's stellar companion, which scientists had almost given up hope of finding. This is a discovery that not only uncovers the mystery of Betelgeuse, but also changes the story we have built about the stars in the universe by looking up at the night sky. And Betelgeuse, shining in the Orion constellation, is the 10th brightest star in our night sky. It's a red supergiant so massive that if it were placed in the position of our Sun, it would engulf the orbits of Mercury, Venus, Earth, and Mars. Its diameter is about 760 times larger than our Sun, and it's 87,000 times brighter than the Sun. But it keeps changing. These changes have been a mystery for our scientists and astronomers for centuries. The Great Dimming Event of 2019. But then in 2019, Betelgeuse did something that drew the attention of the whole world towards it. Its brightness suddenly dropped by 30. This was called the Great Dimming Event. Initially, scientists thought that maybe Betelgeuse was in the final stage of its life and would soon explode as a supernova. A supernova is so bright that it can shine in our night sky for months, as bright as a half moon. We waited, and maybe for the first time we would witness a star dying. Gradually, scientists shifted their focus from the theory of it becoming a supernova to studying it more deeply. Then they found out that this dimming was probably caused by a large cloud of dust, and maybe this cloud came from the surface of Betelgeuse. That means the star expelled a large amount of gas and dust, which later cooled down and formed a cloud that blocked the light. But this discovery was only answering one question, the great dimming of 2019 in Betelgeuse's brightness. Another long 6-year major cycle. So what were scientists looking for as the reason for that? At that time, we didn't have any solid evidence. But in July 2025, scientists made a discovery that has almost solved the mystery of Betelgeuse. With the help of a special instrument called Alopeke installed on the Gemini North Telescope, scientists observed a very dim, that is, faintly shining companion star of Betelgeuse, which was named Sivara. If we understand the meaning of the name Betelgeuse, in Arabic it means the arm of Al-Jawza or shoulder of the giant. So the name of this newly discovered companion is Sivara, which means her bracelet or bangle. This name is absolutely perfect for this star because it is orbiting around Betelgeuse like a bracelet. Sivara is 6 magnitudes less bright than Betelgeuse, which means it is millions of times dimmer than Betelgeuse. Scientists estimate that its mass is about 1.5 to 1.6 times that of our Sun. It is a pre-main sequence star, which means it has not yet started hydrogen fusion. It can also be called a stellar baby, which is still in the early stages of the process of becoming a full-fledged star. When it starts hydrogen fusion, it will become an F-type star, which will be brighter and more massive than the Sun. The most surprising thing about Sivara is its strange orbit. It orbits just 4 astronomical units away from the Betelgeuse star. This distance is 4 times the distance between our Earth and the Sun, but still less than that of Jupiter. We have already talked about the size of Betelgeuse. If it were in our solar system, it would extend up to Mars, so you can imagine how far its massive outer atmosphere would stretch. In fact, its companion Sivara is actually orbiting inside Betelgeuse's atmosphere. This is such a strange thing that scientists had never seen before. Every 6 years, Sivara passes close to Betelgeuse and it completely disturbs the star's outer atmosphere. It creates turmoil there, causing gas and dust to be ejected, which sometimes blocks the light. And this was the reason for the 2019 Great Dimming event because of Sivara's orbit. A 6-year cycle is observed in Betelgeuse's brightness. This discovery not only explains Betelgeuse's behavior, but also shows how such red supergiant stars behave with their companion stars. It wasn't easy to find Sivara. Betelgeuse is so bright that seeing any dim star near it is next to impossible. Just imagine, this star is 87,000 times brighter than our Sun. Even powerful telescopes like the Hubble Space Telescope and Chandra X-ray Observatory, Steve Howells and his team used Betelgeuse, but not to find this companion star. In imaging, the telescope used Gemini North's 8.1-meter giant mirror and the Allope instrument for a very short time. Scientists took thousands of such images and combined them using a special algorithm. This allowed the intense brightness of Betelgeuse to be removed and the faint glow of Sivara to be seen. This image was taken on December 9, 2024, exactly at the time when previous studies had predicted that Sivara could be found at its farthest point, Hala Halki. The confidence level of this discovery is currently 1.5 sigma. Scientists generally require 5 sigma for a discovery to be considered fully confirmed. Halki, the location and timing of Sivara matches the predictions of previous studies, so scientists are considering it almost confirmed. Currently, Betelgeuse is a red supergiant star and there is no doubt that it is in the final stage of its life. It is only 10 million years old, but its enormous mass forces it to burn its nuclear fuel very quickly. Scientists estimate that it will explode as a supernova within the next 1 million years. But the future of Sivara might take an even more dramatic turn. Sivara is so close to it that Betelgeuse's gravitational pull is slowly drawing it in. It is estimated that in the next 10,000 years, Sivara will either be absorbed by Betelgeuse, or if Betelgeuse becomes a supernova before that, it will be completely destroyed. It's a strange pair. One star is at the final stage of its life, while the other star is just being born, but neither of them has time. Besides this, the gravitational interactions between Sivara and Betelgeuse also affect Betelgeuse's rotation and mass loss. This helps us understand why Betelgeuse rotates so fast and why its outer atmosphere is so unstable. The discovery of this companion star Sivara will help scientists understand whether other stars like Betelgeuse also have similar companion stars. This discovery can also help in understanding spectroscopic binaries, that is, pairs of stars that are so close together that it is difficult to see them separately. Scientists will get the next opportunity to observe Sivara more closely in November 2027 when it will be farthest from Betelgeuse. Then, by using instruments like Gemini North and Allope, we will once again gather information about this star. This will not only confirm Sivara but will also help us learn more about its mass, temperature, and its orbit. Betelgeuse has always been a source of fascination for astronomers and ordinary people alike. Its red color, massive size, and its place in the Orion constellation make it a shining gem of the sky. But the discovery of Sivara has made its story even more exciting. A giant star and its small companion are performing a cosmic dance together, and this dance is not only solving the mysteries of Betelgeuse, but also giving us a chance to peek into the depths of the universe. And nature itself gives us these opportunities, understanding and knowing it is truly the beauty of nature. Friends, what are your thoughts? Do let us know in the comments section. If you like this video, please like it and share it with your friends. For more such informative videos, make sure to subscribe to the channel and turn on the bell notification. Friends, we'll see you again soon with another informative video like this. Till then, stay curious, be happy, and goodbye.